We have question 5 from a November 2021 exam paper. Now, keep in mind, to answer question 5 or to answer the trigonometry section, we're going to make use of this cast diagram. You are not going to be given a cast diagram in your question paper or on your formula sheet, so I would recommend memorizing it before you go to the exam. This cast diagram is very important. We are going to refer to it to answer all of the questions. Now, question 5.1, without using a calculator, simplify the following expression to one trigonometric ratio. So we are only supposed to have a single trig ratio. So let us get started. Let's focus on sine of 140 degrees. We can reduce sine of 140 degrees to an angle that is less than 90. Always remember, if the angle is greater than 90, you always reduce it to something less than 90. So to get started, we need to identify first what quadrant it is in. Is it positive or negative in that quadrant? And lastly, reduce it. So let us identify what quadrant is 140 degrees. We know that 140 degrees is greater than 90 but less than 180, meaning that it is in quadrant 2. So this is quadrant 2. Let us actually make a note, as that is something that I've left out. So this is going to be quadrant 1, quadrant 2, quadrant 3, and lastly quadrant 4. So we now know that sine of 140 is in quadrant 2 and sine is positive in quadrant 2. So we now have positive sine. Next, we need to reduce the angle of 140. So we are going to use the reduction formula in quadrant 2, which is 180 minus the angle. So let us get started. So let's just make a quick note. This is in quadrant 2 and it is positive in quadrant 2. Now, to reduce this angle, we are going to do it on the side quickly. So here, if we want to reduce an angle, we are going to use our reduction formula in quadrant 2. So sine of 140, to reduce that, we state the reduction formula in quadrant 2, which is 180 minus the angle, and that is equal to, what angle are we reducing? We are reducing an angle of 140. So that is always going to be your process. Take the reduction formula in that specific quadrant, equate it to the angle you are reducing, and then solve for angle. So here, I'm going to move the 140 to the left, move the angle to the right to make it positive, and the angle is therefore equal to 40 degrees. It is now less than 90. So we have now reduced sine of 140 into positive sine of 90. Next, let us have a look at the second ratio. So we have sine of 360 minus x. Now, this is slightly different to the previous one. Previously, we had an angle. Now, we are given a reduction formula. So this is much easier than being given an angle. When you are given the reduction formula, all you need to do is match that reduction formula, which is 360 minus x, to the reduction formula in the cast diagram. So let us go to the cast diagram and have a look. Where is 360 minus x, or 360 minus some angle? As you can see, that is in quadrant 4, 360 minus some angle. So we now know that this is quadrant 4. So let us make a note of this. But is it positive or negative in quadrant 4? Let's go back and have a look. So we were given sine, but as you can see, only cos is positive in quadrant 4, meaning that sine will be negative. So here we can reduce this into negative sine of x. When you reduce using the reduction formula instead of an angle, all you are going to do is identify whether it is positive or negative in that particular quadrant, and then write down the angle only. This 360 minus part is just to tell you which quadrant it is in. Once you are done reducing, you just write the variable only, the angle only. So that is the numerator. The denominator is already reduced as it is an angle less than 90. Next, let us have a look at tan of negative x. So as you can see, we have negative x, negative angle. So please keep in mind, this is a negative angle. When you are dealing with a negative angle, you have to add 360 in order to turn it into a positive angle. So here, all we are going to do is plus 360 to turn it into a positive angle. So let's do that down here. So we have tan of negative x. When we plus 360, it is going to become tan of 360 minus x. I'm going to put the positive 360 that we added in front to turn it into a positive angle. Then we need to ask ourselves, 360 minus x, what quadrant is that? We take this reduction formula of 360 minus x, match it to the reduction formulas in our cost diagram. As you can see, 360 minus some angle, that is quadrant 4. And we had tan in our question, but we know that only cos is positive in quadrant 4, which means that is going to be negative tan. So here we're going to write negative tan. And now because we've reduced it, we just write down the variable with the angle, which is x. So that is it. That is the last ratio that we are going to reduce. Now, let us compile all of this information. So question 5.1. The first ratio is sine of 140. We know that 140 is an angle between 90 and 180, meaning that it is in the second quadrant, and sine is positive in the second quadrant. Then we can reduce 140 into 40. So our reduced answer is positive sine of 40. Then the next ratio, 360, or rather sine of 360 minus x. 360 minus x is in the fourth quadrant. Sine is negative in the fourth quadrant. So we are going to write negative sine and then reduce it, write down only the angle. It is negative sine of x. Cos of 50 does not need to be reduced. And lastly, we have tan of negative x. This is a negative angle, so we're going to add 360 to make it a positive angle. That will then become tan of 360 minus x. 360 minus x is the reduction formula of the fourth quadrant, meaning that is in the fourth quadrant. We know that tan is negative in the fourth quadrant, so it is going to be negative tan. And then reduce it, write down only the variable, so it is negative tan x. From here, something important to take note of is we have 40 and 50. Always remember that when you have two angles that add up to 90, they are co-ratios. But keep in mind, one has to be sine, one has to be cos, and they have to be one above the other. They have to be in a fraction. So here, these are co-ratios. So keep in mind that when the angles add up to 90 degrees, when you have sine and when you have cos, and when there are one is a numerator, one is a denominator, they're going to cancel out because they are co-ratios. So they cancel each other out. Another important thing to take note of is that the two negative signs will also cancel each other out, therefore leaving you with positive sine x over tan x. Now there's two ways that we can do this. We can identify the ratio of 1 over tan x. Keep in mind tan x is a denominator, meaning that it is 1 over tan x. Alternatively, we can identify the ratio of tan x alone. So I'm going to take the approach of identifying the ratio of tan x only. We know that tan x is equal to sine x over cos x. So in place of tan x, we are going to substitute sine x over cos x. So that is then going to become sine x, the numerator that we are going to bring down, over sine x over cos x. We can rewrite this as sine x divided by sine x over cos x. And because we are dividing by a fraction, we can turn it into multiplication. So we can flip it, becoming sine x times cos x over sine x. And as you can see, we have sine x on top and sine x at the bottom, so they cancel each other out, therefore leaving us with cos x only. So we have simplified that fraction into a single trigonometric ratio. We have simplified 5.1 into cos x only. So that is it. Next, let us move on to question 5.2. Now, question 5.2 states, prove the identity. So we need to prove that the left-hand side is equal to the right-hand side. So we are going to start on the left and simplify it as far as possible till we get the right-hand side. So this is question 5.2. So question 5.2, the left-hand side is negative 2 sine squared x plus cos x plus 1 all over 1 minus cos of 540 minus x. So we need to simplify this and reduce this into 2 cos x minus 1. So let us just write down the solution on top, 2 cos x minus 1. So this is what we need to work towards. Now, from here, you can see that this denominator can be reduced. So let's start over there. What quadrant is 540 minus x? It is bigger than 360. So we need to subtract 360. Always remember, anytime the angle is greater than 360, you're going to continuously subtract 360 until you get something that is less than 360. So here it is going to be minus 360. So we then have cos of 540 minus x. We are going to subtract 360. So it is going to be cos of 180 minus x. Now we need to identify what quadrant is this in. So we're going to take this reduction formula of 180 minus x and match it to the reduction formula in our cost diagram. 180 minus some angle, that is quadrant 2. We know that cos is negative in quadrant 2 because only sine is positive. So we can reduce cos of 180 minus x into negative cos x. Don't forget that this is in quadrant 2 where cos is negative. So we've now reduced that bottom denominator. Let us have a look at 2 sine squared of x. If you notice, this should remind you of a trinomial, of a, we could say of a quadratic trinomial. We have x squared, or we have sine squared. Now, if we were to factorize this trinomial, if we were to try to simplify it, take note that you cannot factorize it if you have both sine and cos, if you have two different ratios. So we need to make it the same ratio. How do we do that? We know that sine squared x is equal to 1 minus cos squared x. It is or you could say it is an identity. So here we know that sine squared x is equal to 1 minus cos squared of x. That is an identity. So let us write this out. So we are still busy with the left-hand side. Now, this sine squared of x, we are going to replace it with 1 minus cos squared of x. So we bring down the negative 2, but in place of sine squared of x, we're going to put 1 minus cos squared of x. Then we bring down the rest of the numerator. So it is plus cos x plus 1. And that is all over the denominator. We bring down the 1, we bring down the negative sign. Then keep in mind we were able to reduce cos of 540 minus x into negative cos x because 540 is greater than 360, so we subtract 360, leaving us with 180 minus x. 180 minus x is in quadrant 2, cos is negative in quadrant 2, so it becomes negative cos x. So here it is negative cos of x. Now, let us simplify this a bit more. So we are going to distribute the negative 2 into the bracket. So that is then going to become minus 2 plus 2 cos squared x plus cos x plus 1, and that is all over. We're then going to distribute this negative into the bracket. Negative times negative is positive, so we have 1 plus cos x. Then we can add up the like terms, so negative 2 plus 1, that gives us negative 1. So it is now 2 cos squared x plus cos x minus 1 all over 1 plus cos x. Now we are going to factorize the numerator. If you struggle with factorizing the trinomial as a trig ratio, what you can do is turn it into x or turn it into k or whatever variable you want to use. So I'm going to do that on the side. So here, if we were to change it, let's state that, so let k be equal to cos x. Okay. Now, if k is equal to cos x, and if we square k and square cos x, square the left, square the right, that means that k squared will be equal to cos squared x. So wherever we see cos x, we can replace it with k. Wherever we see cos squared x, we can replace it with k squared. So that is then going to become 2k squared plus k minus 1 all over 1 plus k. So we've turned it into something that we are more used to, something with just variables instead of our trig ratios. From here, we can factorize the top trinomial. So factors of 2k squared, that is going to be 2k and k. Then factors of negative 1, let's make it negative 1 and positive 1. Now we need to see which is going to give us positive k. You can see that the middle term is positive, so I'm going to multiply positive with the bigger number. So here, I'm going to put plus 1 at the bottom, minus 1 on top. We are going to cross multiply. So that is then going to give us k times negative 1, that is negative k. 2k times positive 1, that is positive 2k. If you add up negative k and positive 2k, you get positive k, which is the middle term. Keep in mind, this is not the only way to factorize a trinomial. This is just the method that I prefer. You can use whichever method you are comfortable with. So from here, our brackets are going to be 2k minus 1 and k plus 1. Now 1 plus k can also be written as k plus 1. I'm just going to write it as k plus 1 so it looks more similar to this bracket over here. But 1 plus k, k plus 1, they are the same thing. So because the top bracket is the same as the bottom bracket, they cancel each other out, therefore leaving you with 2k minus 1. But don't forget, k is equal to cos x. So in place of cos x, don't forget that k is equal to cos x. So in place of k, we are going to replace it with its original cos x. So here, it's going to be 2 cos x minus 1. And as you can see, that is what we were supposed to have originally. That is our right hand side, 2 cos x minus 1. So we can therefore state that the left hand side is equal to the right hand side. And that is it. All we needed to do was reduce, simplify, use our identities, use a bit of algebra, and we are done. Keep in mind that you did not need to convert the cos x into k. You could have just as easily factorized in terms of cos x. Now, let us have a look at the next question. So next we have question 5.3. Given sine of 36 is equal to the square root of 1 minus p squared. So keep in mind we were given the ratio sine of 36. Now, if you were given sine of 36, keep in mind sine is equal to the opposite over the hypotenuse. So just from the information provided, we already know what is the opposite of the triangle. We know what is the hypotenuse of the triangle. Because we have two known sides of a right-angled triangle, that will allow us to find the third side using the theorem of Pythagoras. So this is a diagram question. We're going to use the diagram to then solve for question 5.3.1 and 5.3.2. Something important to take a note of is that 36 is an angle in quadrant 1. It is bigger than 0, smaller than 90. So our triangle is going to be in quadrant 1. So let us have a look at a rough sketch of the diagram in quadrant 1 and then complete this by filling in the opposite side and the hypotenuse. So we were told that sine of 36 is equal to the square root of 1 minus p squared. Now keep in mind, as I mentioned earlier, sine is equal to the opposite over the hypotenuse. If it does not have a denominator, it means there's an invisible 1 at the bottom, which means that the numerator is our opposite side, we can call it y, and the denominator is our hypotenuse, we can call it r. So here we know that the opposite is the square root of 1 minus p squared. Our hypotenuse is 1. As you can see, x is missing, x is unknown. So we need to look for x. To look for x or to find x, we are going to use the theorem of Pythagoras. So here, let us start with that quickly. So we know that the theorem of Pythagoras is r squared equals x squared plus y squared. Our reason is just Pyth, the theorem of Pythagoras. R is 1 and we can square that. X is unknown, that's what we're looking for. Y is the square root of 1 minus p squared, and that is squared. From here we are going to solve for x. So 1 squared is 1, we have x squared, and we know that squared and square root will cancel each other out, leaving us with 1 minus p squared. From here, I'm going to take everything that is not x to the left. So 1 minus 1 plus p squared equals x squared. From here, 1 minus 1 becomes 0, and we have p squared is equal to x squared. We're going to square root both sides. Please keep in mind when you square root something, it becomes positive or negative. So x is then equal to positive or negative p. Because we are in quadrant 1, it means that we have a positive x value. So we are going to go with positive p. So we've now completed our triangle. So let us now answer the questions that follow. So question 5.3.1. What is question 5.3.1? Without using a calculator, determine each of the following in terms of P. Tan of 36. So tan of 36, we know that tan is equal to the opposite over the adjacent. Our opposite, so let us just label these sides quickly. This is the opposite side, also known as y. This is the adjacent side, also known as x. And this is the hypotenuse, also known as r. So tan is equal to the opposite, which is the square root of 1 minus p squared, over the adjacent, which is just p. So tan of 36 is equal to the square root of 1 minus p squared all over p. And that is it. Next we have question 5.3.2. Before we continue, let us just make a note at the top of this page. Always remember SOHCAHTOA when you are dealing with these types of questions. SOHCAHTOA means sine is equal to the opposite over the hypotenuse, cos is equal to the adjacent over the hypotenuse, and tan is equal to the opposite over the adjacent. Now question 5.3.2 states we need to, without using a calculator, find out what is cos of 108 equal to. Now, as you can see, 108 is bigger than 90 degrees. So we need to reduce this. We need to make it less than 90 degrees. So cos of 108. 108 is in the second quadrant. It is bigger than 90, smaller than 180. And we know that cos is negative in the second quadrant because only sine is positive. So we can reduce cos into negative cos. Then we need to reduce the angle. So to reduce the angle, we are going to take the reduction formula in quadrant 2, which is 180 minus the angle, equate it to the angle we need to reduce, which is 108, and then solve for the angle. So let us attempt. So the question is cos of 108 degrees. Now keep in mind, 108 degrees, that is in quadrant 2. And we know that cos is negative in quadrant 2. So this can get simplified into negative cos. Now we need to reduce the angle. To reduce the angle, you take the reduction formula in quadrant 2 and equate it to the angle you are trying to reduce, then solve for the angle or solve for the variable. So I'm going to move 108 to the left, take the angle to the right, and the angle, or you could say the reduced angle, is therefore 72. So cos of 108 can be reduced into negative cos of 72. Now that we have negative cos of 72, we need to ask ourselves, how can we connect that back to the diagram? Because the diagram doesn't have an angle of 72. However, we know that 2 times 36 is 72. So we can turn 72 into 2 times 36, and this will then become a double angle. So let us make a note of that. We know that 2 times 36 is equal to 72. So we are going to turn this into negative cos of 2 times 36. So it's a double angle. We also know that we have 3 double angle formulas. Our 3 double angle formulas are cos of 2x is equal to cos squared of x plus sine squared of x. We have cos 2x is equal to 1 minus 2 sine squared of x. We have cos 2x is equal to 2 cos squared of x minus 1. So these are our three double angle formulas for cos. We need to decide which one we are going to use. So we were previously given the sine ratio. So I'm just going to use the one that has sine in it. So let us just make a note that cos 2x is equal to 1 minus 2 sine squared x, whereby x is going to represent 36. So here it is going to be negative, so we bring down the negative sign, open a bracket. What is cos of 2 times 36? It is 1 minus 2 sine squared. What is the angle? It is 36. Let us turn this into a square bracket. From here, I'm going to distribute the negative into the bracket, making it negative 1 plus 2 sine squared of 36. From here, what is sine of 36? We know that sine of 36 is the square root of 1 minus p squared. It was the original ratio given to us. So in place of sine of 36, we are going to substitute the square root of 1 minus p squared. Don't forget that it is not just sine, it is sine squared. So you have to square this bracket. And we know that the square root and the squared will end up cancelling each other out, leaving us with 1, or rather negative 1, plus 2 into 1 minus p squared. From here we can distribute the 2 into the bracket, and we have negative 1 plus 2 minus 2p squared. From here, negative 1 plus 2, that is positive 1, leaving us with 1 minus 2p squared as our final answer. So that is it. It is 1 minus 2p squared. All you had to do was reduce the angle because you were given an angle greater than 90 degrees. Once you reduced it, you had to identify the connection between 72 and 36. If you could not identify the connection between them, you would have struggled to continue from that point. So we know that double 36 is 72. Therefore, we were able to use double angles. And that is it. Next, let us have a look at question 6 from this November 2021 exam paper. Now, question 6.1, given that cos of alpha minus beta is equal to cos of alpha, cos of beta, plus sine of alpha, sine of beta. So that is our compound angle formula. Question 6.1.1, use the given identity to derive a formula for cos of alpha plus beta. So we basically need to use the identity given in 6.1 to find out what is cos of alpha plus beta equal to. So let us get started. Question 6.1.1. We need to identify what is cos of alpha plus beta equal to. Now here we know that a positive sign can be broken up into two negatives. So we know that a negative times a negative is equal to a positive. So we can rewrite this as cos of alpha minus negative beta If you were to multiply the two negative signs, it will take you back to the original. Now, from here, we are going to make use of the previously given identity. We know that cos of alpha minus beta is equal to this right-hand side here. So we are going to use the exact same formula to expand this. So here we have cos of the first angle, cos of the second angle. Now our first angle is alpha. Our second angle is negative beta. Then we have a plus sign. Next we have sine of the first angle, sine of the second angle. Our first angle is alpha, and our second angle is negative beta. Now we need to reduce this. We need to simplify this negative beta. So cos of negative beta, keep in mind this is a negative angle. So if you want to, you can plus 360 to turn it into a positive angle. So here we're going to plus 360 to turn it into a positive angle. So that is then going to become cos of 360 minus beta. All I did was add 360, so I put it in front. It's still positive 360 and the original negative beta. From here, we can reduce this. We know 360 minus beta is in the fourth quadrant. If we go back to our cos diagram, you can see for yourself that 360 minus some angle, that is the fourth quadrant. And we know that cos is positive in the fourth quadrant. So this is going to get reduced into positive cos of the angle. So it is now positive cos beta. Then let us have a look at the second one, this sine of negative beta. So keep in mind for sine of negative beta, once again, we are just going to plus 360 because it is a negative angle. That is then going to give us sine of 360 minus beta. We know that 360 minus beta is the fourth quadrant, and sine is negative in the fourth quadrant because only cos is positive in the fourth quadrant. So this becomes negative sine of beta. Now, from here, let us just combine this quickly. So we bring down cos of alpha. Cos of negative beta was simplified into cos of beta. Then bring down the positive sign, bring down sine of alpha. Then we know that sine of negative beta was simplified into negative sine beta. From here, we can multiply the positive sine alpha and the negative sine beta. So positive and negative, that gives us a negative. So that is going to be minus sine of alpha, sine of beta. Now, if you look at your compound angle formulas, you can take this a step further and simplify it if you want to. But let us go back to the original question quickly. Stated, use the given identity to derive a formula. So we've now derived a formula. So if you simplify it and take it to the next step as per your formula sheet, you would end up with cos of alpha plus beta, which is the original. But you don't have to because that's just taking you backwards. So we can stop here. We've now derived a formula. So if we want to, we can then conclude to state, therefore, cos of alpha plus beta is equal to cos of alpha cos of beta minus sine of alpha sine of beta. And that is it. We have now derived a formula for cos of alpha plus beta. All you had to do was make use of algebra, a little bit of reduction, and you are done. Then we have question 6.1.2. Now, question 6.1.2 states, simplify completely. So we need to simplify 2 cos 6x cos 4x minus cos 10x plus 2 sine squared x. So let us write that down quickly. So that is something to take note of is that 6x and 4x when added will produce 10x. So we can turn cos of 10x into a compound angle formula. So here we have 2 cos 6x cos 4x minus, I'm going to turn cos of 10x into 6x plus 4x, and that is plus 2 sine squared x. From here we can use our compound angle formula, which is cos of the first angle plus the second angle is equal to cos of the first angle cos of the second angle minus sine of the first angle sine of the second angle. Now keep in mind, A is going to represent 6x and B is going to represent 4x. So from here, we're going to have 2 cos 6x cos 4x. So we bring down the first part minus, and then we substitute our compound angle in place of this cos of 6x plus 4x. So here it is going to be cos of the first angle, cos of the second angle, minus sine of the first angle, sine of the second angle. Don't forget about positive 2 sine squared x. From here, we are going to distribute the negative into the bracket. So negative times this positive cos 6x cos 4x, and then negative times this negative sine 6x sine 4x. So that is then going to give us 2 cos 6x cos 4x minus cos 6x cos 4x plus sine 6x sine 4x. And don't forget to bring down the positive 2 sine squared x. From here, you should notice that 2 cos 6x cos 4x minus cos 6x cos 4x. Another way of looking at that is 2xy minus xy. So we have 2 of the same variable minus 1 of the same variable. Those are like terms. So that is going to end up giving us just cos 6x cos 4x. Then we bring down plus sine 6x sine 4x plus 2 sine squared x. From here, something important to take note of is our compound angle. We have cos of the first angle, cos of the second angle, sine of the first angle, sine of the second angle. Something to take note of or to help you identify it is the repetition of cos cos sine sine, or the repetition of the angle. So this is then going to be cos of the first angle, cos of the second angle, plus sine of the first angle, sine of the second angle is equal to the compound formula cos of A minus B, whereby A is 6x and B is 4x. So that is going to become cos of 6x minus 4x. And don't forget to bring down 2 sine squared x. From here, 6x minus 4x, that is just 2x. Now we need to try to simplify this. Something important to take note of is that cos 2x is a double angle. So we can turn this into something that has sine squared in it. So we can add it to this 2 sine squared x. We know that cos 2x is equal to 1 minus 2 sine squared x. So in place of cos 2x, we're going to replace it with 1 minus 2 sine squared x. And then bring down positive 2 sine squared x. Now please take note that negative 2 sine squared x plus 2 sine squared x becomes 0, therefore leaving us with positive 1 as our answer. So for question 6.1.2, we've simplified that expression to 1, and that is it. All we needed to do was make use of compound angles, our double angle formulas, and a bit of algebra, and we are done. Our last question, question 6.2, and that is a 7-mark question. We need to determine the general solution of tan x equals 2 sine 2x, where cos x is less than 0, meaning that cos x has to be negative. So let us get started with that one. Two important things to take note of is that tan x is equal to sine x over cos x, and that sine 2x is a double angle, and that is equal to 2 sine x cos x. So let us substitute. Sine x is going to become, or rather tan x is going to become sine x over cos x. So that is the left hand side. The right hand side, we bring down the 2, and in place of sine 2x, we're going to put its double angle formula. From here, we can multiply the 2 and 2, giving us sine x over cos x is equal to 4 sine x cos x. We can then cross multiply. So we multiply the cos x with the right hand side and the denominator of the right, which is an invisible 1, with sine x. We will therefore have sine x equals 4 sine x times cos squared x. Keep in mind, cos x times cos x gives us cos squared x. From here, we are going to move everything to the left. Then you should notice we have a common factor of sine x. So that is then going to give us sine x into 1 minus 4 cos squared x equals 0. We can separate them and have sine x equals 0, or 1 minus 4 cos squared x equals 0. We can take 1 to the other side, making it minus 4 cos squared x equals negative 1. We can divide both sides by negative 4, giving us cos squared of x equals 1 over 4. From here, to get rid of the squared, we can square root both sides. However, keep in mind the original restriction stated that cos x has to be less than 0, meaning negative. So we are going to proceed with cos x equals negative 1 over 2. So please keep that in mind. So we have two solutions. We have sine x equals 0, and we have cos x equals negative a half. Now I'm going to focus on sine x equals 0 first. So let us have a look at that. Now, sine x equals 0. When is sine x equal to 0? If we were to draw a sine graph, a basic sine graph, you will be able to identify that sine x is equal to 0 at x is equal to 0, x is equal to 180, and x is equal to 360, and so on and so on. So from there, what we are going to do is choose one of those points. We are going to choose the point of 180. So what I'm going to do is I'm going to quickly draw a rough sketch of a sine graph. If you want to, on your calculator, you can press mode, you can press table, you can press f of x equals sine x. Your starting point, you can make it 0. Your ending point, you can make it 360, and then your step, you can make it 90. And then you'll be able to see at which points sine x is equal to 0. So this is our y equals sine x graph. As you can see, sine x is equal to 0 at 0, 180, and 360. So our answer here is going to be x equals 180 plus k times 360, where k is an element of integers. So this is going to be our answer. Always remember, when you are dealing with sine and cos, you use plus k times 360. When you're dealing with tan, you use plus k times 180. Next, let us have a look at the second part. Cos x equals negative a half. Now keep in mind, because cos x is equal to a negative answer, or something that is negative, it means that it is going to be in quadrant 2 and quadrant 3. That is where our solutions are going to be in. If cos x was equal to something positive, our solutions would be in quadrant 1 and 4, because those are the solutions in which cos x is positive. Now, from here, let us identify our reference angle. So to find the reference angle, all you're going to do is move cos to the other side. So your reference angle is equal to cos inverse of 1 over 2. Please take note that when finding your reference angle, you do not include the negative sign. Now, you can put this into your calculator, and you will then end up with a reference angle of 60 degrees. Now that we have the reference angle, we can find our solutions in quadrant 2 and 3. So let us start with quadrant 2 first. So you'll state the angle, which is x, is equal to the reduction formula in quadrant 2, which is 180 minus the reference angle plus k times 360. Please take note, the plus k times 360 is not part of your reduction formula. Only this part here is the reduction formula. Now, we're going to substitute. So it is going to be 180 minus 60 plus k times 360. And we therefore have the solution in quadrant 2 as equal to 120 plus k times 360, where k is an element of integers. That is our first solution in quadrant 2. Then our solution in quadrant 3, we have x is equal to the reduction formula in quadrant 3. Then we include plus k times 360. From here, we can substitute the reference angle, which is 60 degrees. And we therefore have x is equal to 240 plus k times 360, where k is an element of integers. So that is it. Because cos was equal to something negative, our solutions are in the quadrant that cos is negative in, quadrant 2 and quadrant 3. From there, we substitute our reference angle into the reduction formulas, simplify, and we are done. And that is it.